worksheet from yesterday out. If you didn't do it, that's okay. You're going to be writing, well, it's not okay, honestly, but you don't need to have done it to be following along with us. I want you to be writing what we're writing. There we go. I want you to be working along with us as we go over problems, the kids that did do it. And then for the last part of class, we're going to be working problems from today's worksheet together. If you weren't here yesterday, go grab the worksheet. 16, 17, and 18, they're all four-term polynomials that we factor. So look at, you got your notes from yesterday out, Keyshawn? Or the other day, the Chapter 8 review notes. Everybody should have the Chapter 8 review notes out. Ideally, your other notes this morning, you got the B. Here's your B worksheet. There you go. Okay, we're on 16. Everybody turn to 16. Pick your pencil up. You're going to be writing with me. If you did not do 16, 17, or 18, we're going to be doing one of those. So let's make sure you're ready. So the very first thing we always do when we factor is what? What's the very first thing we always have to do when we factor? Do you remember? Find the GCF data. That's exactly right. We are going to group if there's four terms, Keisha, you're right. On this particular problem we're talking about, we're going to be grouping. But we do want to double check that there is not a greatest common factor before we do that. So for number 16, number 17, do you have a particular one you prefer to do, Keisha? Of those three, any one in particular? I don't think there's a greatest common factor in any of them. Yeah, so there's not a greatest common factor. They're all going to be worked almost exactly the same way. They're all kind of ugly because they have more than one variable. We don't even like that, right? Yeah. So you have one of the things I'd like for you to do tomorrow is to not let how it looks freak you out, right? Because the steps work, no matter if there is more than one variable, right? Just have some trust in the steps. So let's do it. You said group first, so we're going to do two groups. You remember what you do next? Yes, find the GCF of those groups. So if it's four terms, if you're looking in your notes on your Chapter 8 review notes, after you do the greatest common factor, the question is, are there four terms? If there are four terms, we use our 8-8 notes. And the 8-8 notes will tell you plot a greatest common factor, then group the four terms into two groups. Four terms, if they're factorable, are going to be factored into two binomials. So to find the first binomial, Keisha said we're going to find the greatest common factor of each group. What's the greatest common factor of the first group, Keisha? So for numerically 1, what about the variable? X, that's right. So there's not a number. We don't pull a 1 out, right? What's the greatest common factor of the second group, Keisha? Y, that's right. And this is a plus, so it's plus Y. What do we do now? We divide. What do we divide and by what? We divide by X. What do we divide? The first group or the second group? First group. X squared divided by X is X, and that's a plus, so we bring a plus. And what is 2X divided by X? 2, that's right, because X divided by X is 1. 2 times 1 is 2. So that's it. It does not matter if you have more than one variable. They're exactly the same, okay? I understand those are ugly, right? Two variables looks intimidating, but we do them exactly the same as if there's only one variable. Anybody else have questions on yesterday's assignment? Sorry? So, Keyshawn's looking at 17 modes, well, that's everybody benefit, right? So if we group here, there's not a greatest common factor here. We're still going to have to keep our new one. Remember, if there's not a greatest common factor, just put on a 1. Okay? If there's not a greatest common factor, it's a 1. And here, that's going to be negative a. So minus a. Does that make sense? Ooh, wait. So this is one that we may need to rearrange. Yeah, let's rearrange. So if we rearrange, that's not going to work that way. Let's rearrange our terms. So we said normally we would put them in standard form, but you might have to rearrange them. We've never had to rearrange them yet, but this one would be helpful. So what if we put 3a squared minus 6a, okay, that makes sense, Keishan? Because we see there's a 3 and an a, and then I'm going to put plus ab minus 2b, but you can put those in whatever order. So now there's a b that will come out of both of those. Usually we don't have to take it out of standard form, but this one is better if we do. Does that make sense? So now, two groups. Greatest common factor here, 3 numerically, and a for the variable. What's the greatest common factor of this second group, Keishan? B, yeah, and we're going to do plus b because it's a plus first. So now we would divide by 3a. So that's going to be 3 divided by 3 is 1, a squared divided by a is a. Negative 6 divided by 3 is negative 2, and a divided by a is 1, so that would be our final answer. So rearrange to put those terms next to each other that have a common factor, especially for the first two. Okay? 7? Yes. Okay, we're going to go back. Anybody need me to leave it there for a sec? Y'all caught up? All right, you write that one down? Okay, Xavier, you got it written down? Brooklyn, you got it written down? Okay, Brandon, did you get that one right? Okay. All right, 7. So what we need to do is go through our chapter 8 review notes and follow those steps, follow those guidelines. First thing it tells us to do is look for a greatest common factor. I'm going to rearrange it. I'm going to put it in order in standard form. I don't know that it really matters, but I like it better that way. And this one I don't think it'll matter. So remember, greatest degree to least degree. Degree of 3, degree of 2, degree of 1. Everybody cool? That makes sense, Fatima? All right, is there a greatest common factor? What is it? 2, is there anything else? 2x, yeah. So our notes say, determine the greatest common factor, so is it, and then factor it out. That's what we're going to do. So 2x times, what gives me x cubed? Well, that would be x squared. Does that make sense? 2x times what will give me 12x squared? That would be 6x. Okay. There's a plus here. 2x times what will give me 18x? That would be 9. Okay? So now, this has to be my answer, but really what I'm doing is I'm looking to see if this can be factored further. Right? And so, this is an x squared plus bx plus c, 3-term trinomial, right? It's trinomial, 3-term polynomial. So we could use the strategy we learned in 3.5, but this is also a special product. So we could also use the strategy we learned for the shortcuts, right? So I've told you it's a perfect square trinomial. I know it's a perfect square trinomial because, for one thing, this is one of the most important things. That has to be a plus. This has to be a perfect square. Is x squared a perfect square? This has to be a perfect square. It's 9 a perfect square. Okay. So, x squared is a perfect square. What's the square root of x squared? And what's the square root of 9? 3. So if this is a perfect square trinomial, we'll multiply the square roots of the first and last term, multiply it by 2, and if that equals that, then this is a perfect square trinomial. Remember, so this would be from our 8-7 note. So now we can use the shortcut, which is, give yourself a binomial of squares. Do you remember what to do next? It is x plus 3. So the square root of the first term goes in the first spot, and the square root of the last term goes in the last spot, and this is the operation we use. So that would be your final answer. You could use the 3-5 strategy for that as well, but you don't need to. But it's okay if you send 8-5 rather. Alright, any questions on that one? Any other questions on yesterday's assignment? Can you see it? Do you have any? No? Brandon, do you have any? Any questions on the B worksheet? 25? 21? Sure. So 21, if we're looking at our review notes, the first thing it always asks is there a greatest common factor? Is there a greatest common factor here, Keyshawn? Okay. So, does it sound like I'm repeating myself on this stuff, you guys? And that's why it takes longer for us to do it, because I am repeating myself. But when you're doing it in your head, it's a little bit quicker. You're just running through this stuff really fast once you learn the steps, right? So what we always have to check if there's a greatest common factor. There's not. This is an A. There's an A in both of these, but not here. There's a 3 in both of those, but not there. There's a D in these two, but not in these two. So there is no greatest common factor. So the next thing we do is look at our notes. How many terms are there? If there's 4 terms, and there are, 1, 2, 3, 4, we group them. 2 groups. Now what do we do, Keyshawn? Well, first off, we know there's going to be 2 binomials, right? So what do we do next? Okay. What would that be? Okay, so let's look at this. AB is really A times D. Does that make sense, Keyshawn? So these are the factors of AB. 3A, the factors are 3 times A. So what do they have in common? What do they have that's the same? A, that's right. So that makes A our greatest common factor. So A goes here. What is the greatest common factor of B? Well, D squared is D times D, right? And 3D is 3 times D. So what is the greatest common factor that those two have? D, that's right. 1D, because this one only has 1, right? Now the trick is here, remember, Keyshawn, is this going to be a plus or minus D? Yeah, because if this is a minus, our greatest common factor for that second term is minus. Now what do? We divide. What do we divide? Divide what by A? The first group. The first group is divided by the first greatest common factor. What is 80 divided by A, Keyshawn? D, that's right. Let's cancel out 1. That's D. It's a plus. What's 3A divided by A? That's right. A divided by A. That's 1. 3 times 1 is 3. That's it. So it looks really hard, but it's exactly the same way every time. questions on these? Okay. Anybody else have questions on yesterday's worksheet? Nicole, you good? Okay. Well, then we can go ahead and start working some problems in today's worksheet if you like. Well, whether you like or not, some of you need help. Some of you are working ahead, and that's great. But you can look through and see, are there problems that are intimidating you or you're overwhelmed by? Akira? 5, Brandon? 5 and 16. Nicole? 11. Anybody else? 10? What's up? 21. Okay, well, let's start with these. And we'll start with the biggest and work our way up. So we'll start with 5. So 5. If we're looking at our chapter 8 review notes, you can go to the end. Chapter 8 review notes, it asks us the very first thing always to what? Select the greatest common factor. What's the greatest common factor of those? A. A times 15, A minus. Perfect. Okay. Is there anything else we can factor out here? Well, that's it. Yeah. So sometimes they seem like they're too easy. They're not too easy. That's just the problem, right? The hard part is knowing that you're done, right? Okay. The next one, I can't remember. I think the next one is 10. So we're going to go down to number 10. I think Jade and you after this one, right, bud? Okay. How many terms? 4. Is there a greatest common factor? Sorry? Not in all of them, that's right. If there's not one in all of them, there's not one. You're exactly right. At first glance, I see I'm thinking 4s or 7s, but no, there's not a common factor of all of them. So this is our grouping. All we're doing here is grouping. It's crazy because there's more than one variable, and that's intimidating. But I promise you, it's exactly the same. So you're still going to group. Do you remember what you do after you group, Jaden? So this would be from your 8-8 note. Factoring by grouping means the very first thing we do is we group, and then if it's possible, we know we're going to have 2 binomial factors. So now we're going to look at this first group, Jaden, we're going to find the greatest common factor of that group. What's the greatest common factor of 12xy and 28x? X's part, is there a numerical greatest common factor? The number that will come out of both 12 and 28? 4. Perfect. So 4x is the greatest common factor of the first group. What's the greatest common factor of the second group, Jaden? Yeah. Here, so remember, our first group is the sum of the greatest common factors of this group and this group. The greatest common factor of this group is 4x. The greatest common factor of this group is 3. So that is the first factor of our answer. Do you remember how to find the second factor of the Jaden? By first group or second group? Yep. First group gets divided by the first greatest common factor. And 12 divided by 4 is 3. X's cancel out and leaves me a y. This is minus, so minus goes here. 28 divided by 4 is 7. And x divided by x is the simplify or cancel out. Okay? So it looks ugly, but it's exactly the same. So this is not much work, but you do have to show me some work on these. But this is all I require. The groups, what did you divide, what is the greatest common factor, what did you divide out of there, okay? 11, somebody asked number 11. Number 11 looks even uglier. But number 11, I promise you, is exactly the same as number 10. Who asked for number 11? Nicole? Okay. Is there anything we can take out of all 4 terms, Nicole? No, there's not. I want to take out a 2, but now look here, there's no 2. See, all of these variables, I want to get rid of one of those, but there's not one that they all have in common. So 4 terms, what do we do to factor the 4 terms? We group them, that's right. So we know they're going to be 2 groups down here, so give yourself the 2 groups, right? So what do we do next, Jacoy? ADAS 8 notes, if you guys are following along, look at your ADAS 8 notes. After you group, what do? Yep, the greatest common factor of each group, and we're going to put them in the first thing. Our notes were a little bit more detailed in our notes, but as we've gone through, we can go directly from greatest common factor going in here. What's the greatest common factor of these 2 terms? Look at the numbers first. What's the greatest common factor of the numbers? 3, that's right. What's the greatest common factor of the variable? It's a C. C. What's the greatest common factor of the second group? Look at the numbers first. 2 is a plus, because that's a plus. And how about the variable? B. Okay? What do we do now? Perfect. Divide the first group by the first greatest common factor. 15 divided by 3 is 5. Yep, 5, 2. Those C's cancel out. Simplify to 1. 24 divided by 3. 8y, that's right. The C's cancel out. So it looks really hard and ugly, but it's exactly the same as the ones with only one variable, right? There was 4 variables though? A lot of variables, right? But it's exactly the same. If you just follow the same steps every time, when you're looking for the greatest common factors, always look at the number and then the variables to make sure you get everything. Okay, was 16 the next one? Yes, 16. All right, y'all caught up with me? All right, you caught up with me? Xavier, will you post a Chromebook for me, guys? I know you're not on it, but I need everybody to post it. Okay, 16. Same thing. 2 after 16? Okay, Brandon, we've done 2 like this. Tell me what to do. Group them, very good. After we group them, what do? We give ourselves 2 groups here, right? I'll give you that hint. Now what? Yes, greatest common factor of each group. What's the greatest common factor of the first group? Perfect. How about the second group? B, plus B. Now what do? Yep, what do I divide? Yes, so the first group is divided by the first greatest common factor. That's exactly right. What's AX divided by A, Brandon? Remember, A times X divided by A, those simplify to 1, right? So what do we have left? X plus, and then AY divided by A, what do we get? A times Y divided by A, then A simplify to 1. 1 times Y is Y. That's it. That's all the same. That's what I'm saying is this unit, this chapter is one of the few where I can give you steps. So if you follow the steps, every time the steps work. Now that's if they're factors, right? But if you use the steps, especially for the trinomials, you'll learn that the steps will bring you to the pair of factors that you're looking for. If there's not a pair of factors that will equal the middle summation, then it can't be factors, right? So that's the trick on that. But other than that, the rule book every time. The next one, what was the next problem? You guys remember? 21. Good job. Lesson 21. Is that you, Brooklyn? All right. I love this one. You know why I love this one? Because everyone, if you're paying attention to me right now, will be able to get this on the test. You're keeping me with. Sorry? Yep. Okay, so I love that you have a plus and a minus in a binomial. Since parts of this would be right for some problems, but if there's two terms, everybody look at your chapter 8 review notes and go all the way to the bottom where it says, are there two terms? You see it right here, it says, are there two terms? If so, is it a difference of squares? If so, use 8-7 notes. If not, it can't be factored anymore. So, if there are two factors, can we pull a greatest common factor out of either of those, Brooklyn? Is there anything that both terms have in common? No. So they can't be factored that way. The only two-term polynomials that can be factored have, besides pulling a greatest common factor out, have to be a difference. What does it mean to be a difference? Subtraction, that's right. That one's not a subtraction, right? So it's a difference of squares is a perfect square minus a perfect square. This one tricks kids up because the first number, perfect square, because 6 times 6 is 36. So I like how you were I like that one stumped you because that means you were thinking about it, right? 6 times 6 is 36, that is a perfect square. The last term, x squared, x times x gives me x squared. Remember, a perfect square is a product of the answer of two identical factors, right? So 6, the number 6 can't be a perfect square because it's only factors, 1 is 6, 2 and 3, none of them are identical. X squared, x times x. 36, 6 times 6. So the problem with this one is, it's a plus. It's not a difference. So this one is easy. If you know that, because you just told me it's time. And what I want you to tell me is, because it's not a difference. Right? If you factor that, sometimes kids will factor it like it's 36 minus x squared. Right? We have a shortcut for that. But if it's not a minus, and you can't pull a greatest common factor off, if it's only two terms, we can't do anything else to it. Okay? Any other questions on today's assignment? We've got some more time. Sure? 12. Okay. So we factor anything out of these? I don't think you can. I don't like this one, Karen. Do you like it? Okay, we can't take a variable out. Not a perfect square. 139. So the way I look, so they're not divisible by 2. They're not divisible by 3. You know how I know they're not divisible by 3? You do what's the trick? Okay, so the trick is for 3. 3 plus 0 is 3. 3 is divisible by 3, so 30 is. But 139, 1 plus 3 plus 9, that's 13, right? 13 is not divisible by 3, so 139 can't be divisible by 3. So that's the trick. If the sum of the digits are divisible by 3, then that number is, right? So I don't think it's factorable. I'm going to cheat real quick here because if it is, it's going to take us a lot of time. Late? Yeah. Wait, what time do you get out, late? 19, yes, hurry back so we can beat the, I can't get my words out, beat the 10-minute mark. Oh, I forgot, it's over here. I already know it. So if that one's factorable, ooh, it is. All right, so I didn't want to do all the work if it wasn't factorable, but it is. So here we go. You ready? I suggest everyone follow along with me because I know you don't want to do this one by yourself because I don't even want to do this one. All right? So how many terms are here, Akira? 3. So looking at our notes, our review notes, we had 2 forms of 3 terms, or 3 trinomials. So we had an x squared plus bx plus c, or an ax squared plus bx plus c. So which is this one, Akira? Ax, yes, right, ax squared plus bx plus c. So this would be our 8-6 notes, and we would eventually use the 8-8. This is the one where we have to turn this into 4 terms and then factor by grouping first, splitting the middle term. So we've got to do that ugly. This one's huge. Normally I don't mind these at all, but I always hate to find the factors of really big numbers, but it's okay. A times C. What is the A and C here, Akira? 30 and 154. You're exactly right. So we're going to multiply that. 4620. The difference, so this is a plus and this is a minus. So remember, this is where we give ourselves our x. This time the x, so our product, is a positive 4620, but our sum is going to be negative 139. Got it? Okay. So factors of 4620 that would have a difference of 139. No sense in doing a 1 or 2. 3 will come out of it, but I don't think there's much reason to do that, but let's do it. 4620 divided by 3 is 1540, so 3 times 1540, that's, if they're both negative, so we're adding together, that's not even close to 139, so we need a bigger number. Let's try 6. 4620 divided by 6. Can't do it for some reason. Oh, 770. Those are not close. So really what we're doing is that would be 6 plus 770, right? So not even close. So let's try 20. I think 20 will come out of both of them. So this is all we're doing. It's trial and error. This is 220 rather, times 231. So we're getting closer, but not close enough. Will a 40 come out of it? Or a 30? Let's try 30. 4620 divided by 30. 46, so 30 times 154. But if you add those together, you don't get 139. So this is the process. 40 will not come out of it. Let's see. 4620. 50 won't come out of it. Let's see how close we get with 50. 4620 divided by, I know it's not a 50, 92.4. So 50 and 92.4 are getting close to our answer though, but they're not, it's not a whole number. So let's try 55. 4620 divided by 55. Ooh. So 55 times 84. What is the sum of 55 and 84? Ooh, jackpot. 55 plus 84 equals 139. Okay? So that's what we're doing. We're working until we get them close enough together and finding our factors. Okay, now, these have to be negative, because our 139 is negative, so negative 55, negative 84. So this is where we split this middle term, so we rewrite it so it looks exactly the same, except we're going to split this. So 30x squared and 154 have to be the same. But now we're splitting, so this will be minus 55x minus 84x. Does that make sense, Akira? So from here, we use our 8-8 notes. We're going to group them. What do we do next, Akira? Okay. What's the GCF of the first group? 5x, yep. And what about the second group? I have no idea. So, divided by 2. Say it again. The second group, so it's 6. So we need the greatest common factor of 84 and 154. 14. 84 divided by 14 is 6. Okay? So, and 154 divided by 14 is 11. Oh, I like it. Okay, 6. Is that what you said? Yeah. That's right. Now what do we do, Akira? Or, who asked this one, Akira? What do we do next? All right. 5x and 5x. 30 divided by 5 is 6. X squared divided by x is x. Minus, minus. 55 divided by 5 is 11, and x minus, or divided by x simplifies. So that is our final answer. So the hardest part here was finding those factors of that humongo number. All right? Yeah, same. I didn't want to spend a bunch of time on it if it weren't factorable. So, but that is the process. It did take a minute. We are getting out of here in a few minutes, but we can work one more problem. Anybody see one? Kendall, what you doing, honey? Oh, okay. And have another problem? Anybody want to work on another problem? Kendall? Oh, 14, yes. I don't know why I thought you said. Okay, so let's try. Let's see. Let me try that again. 84 divided by 14. Okay, yeah, I did the opposite. Yes, you're right. Thanks, Kendall. 14, and then that would still be the same. It would be, thank you. Okay. Yes, they both have to be negative. That's the only way we get that positive. Yep. Negative, negative, yep. Good job. All right, anybody else have a problem you want to work before we go? We can squeeze in one last problem. If we do one together, that's one less you have to do, right? Kendall? 7? Lee? Today's assignment? Oh, sure. Now, here's the thing. We did 7, honey. Oh, that's not today's. My bad. Okay, there we go. Okay. Remember, Lee, we did a bunch of these together, so to study for the test tonight, go home and work the ones that we did together on your own, right? You can just write the problems on a list, a plain piece of paper, and then go through and see if you can work them on your own, okay? Because you don't get all the practice when we do them together. All right, 7. Kendall, you with me? So this is, for the sake of time, we only have 4 minutes. I'm going to go through it a little bit quicker. This is a trinomial, 3 terms. It's in the form of x squared plus bx plus c. So we have a strategy for that. That would be from our 8-5 notes. But I think this is a perfect square trinomial, which means we have a shortcut for it. So I'm going to double check that it's a perfect square trinomial. Is the first term a perfect square, Kendall? Is y squared a perfect square? It is. Because y times y, right, has duplicate factors. Is 100 a perfect square? Arctic says yes. What do you think, Kendall? It is, because 10 times 10 is 100. Now, if the square root of the first one times the square root of the second one, but these are the square roots, times 2 equals this one, now we can use our shortcut for perfect square trinomials, which means binomial squared. So it's the square root of the first one, the square root of the second one, and whatever the sign is here. Oh, by the way, it does have to be a plus here to be a perfect square trinomial. So that would be your answer. Any questions? You good, Kendall? Okay. You want to come talk to me real quick, Kendall?